Assalamualaikum and hi, my name is Muhammad Izzat Syami bin Muhammad Fauzi and my matrix number is DE210075. In this case study, I will explain about our introduction, which is about interpolation technique. In this case study, interpolation technique are used to solve the problem. Interpolation is a mathematical method for estimate value between known data point. In interpolate a function or curve that goes over the available data point and allows to approximate the value of an unknown point within the data range. Interpolation primary purpose is to fill in the gap between data point and produce a continuous representation of data set. Two methods of interpolation used in the case study, which is Newton divided difference and Lagrange interpolation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Lukman bin Zulkifli from Group 3 Numerical Methods. My matrix number is DE210080. Today I will present my part, which is methodology. So first, what are the suitable methods to solve the problem? The Lagrange interpolation and Newton divided different methods are the most appropriate numerical techniques to resolve it, because the Lagrange interpolation approach uses a graph to get sample data that may be used to construct approximation. It is appropriate for use in this study. Next, Newton division method may be used to calculate a large amount of data with an infinite number of n. Next is three method, which is Lagrange interpolation, Newton's divided difference, and the third one is simulation. First is Lagrange interpolation based on data from a general problem. Data on capacity and electricity generation from solar from 2013 to 2021 are collected to make an analysis. The first step is making a table of data that make it easier to analyze. From the table, takes the value in 2019 and 2021 as linear approximation samples. Next is Newton divided difference. Newton's divided difference was used to find F 2022. It needs to use by table years VS5. The step is to find all F1, F2, F3 and F4 by adding all Fi. Fn, which is F 2020, F gotten. Third one is simulation on Maple software. To estimate value, we use the Maple software. Simply enter the value into this software automated calculator and it will perform the math for us. It was once used to ensure that the result of a manual calculation and an automated software calculation were the same. I think that's all for my part.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Hazim bin Nur Tajuddin. My number metric is DE210043, and today I will continue the presentation about the manual calculation for Lagrange interpolation. Alright, first and foremost, see our chosen problem from the engineering industry. We have solar panel generation is one of our future electrical power generation sources because it is a renewable energy sources. Below shows a statistic from World in data about the electricity generation from solar in Malaysia. Based on the table, determine the electricity generation from solar in years 2020. So, as you can see below, the table is they not stated the years the electricity generation from solar in 2020. So we choose to use Lagrange interpolation to solve this problem to find the electricity generation from solar in 2020. As we know that in Lagrange interpolation there are four different order. So let's see the first order first. The first order we have linear approximation. If you can see here, uh, this is the formula for the linear approximation. So after we have the formula, we choose the data needed for the formula. So as you can see here, we have two different data needed. So we choose two different data in the middle of 2020. So we choose 2090 and 2021. Then to solve this problem, we need to choose the years as the x and the electricity generation from solar in F. So we insert the data into the formula and then we will get the answer for the linear approximation is 1.22 terawatt hour. Next, we have the second order quadratic approximation. So as stated in linear approximation, we need to put the formula first to solve this problem. So this is the formula for quadratic approximation. Then we choose the data needed in for the quadratic approximation. As you can see here, we have three different inputs. So we need three different data. So we choose 2017, 2019, and 2021. So the years will be the X and the electricity generation from solar will be the F. So we just input the data. We just put the data into the formula and then we will get the answer for quadratic approximation is 1.2263 terawatt hour. Next, we have the third order of Lagrange interpolation is cubic approximation. So this is the formula for the cubic approximation. So as you can see here, we have four different input needed. So we need four data for this method. So we choose 2019, 2017, 2019, and 2021. So here we choose the year as the X and the electricity for generation from solar is df. So we just insert the data into the formula and then we will get the answer for cubic approximation is 1.2639 terawatt hour. Okay, lastly, the first order of Lagrange interpolation is quartic approximation. Here are the formula of the quartic approximation. Then, as you can see here, we have five different inputs. So we need five different data needed in this method. So we choose 2013, 2015, 2017, 2019, and 2021. The years will be the X and the solar electricity generation from solar will be the F. So we just put the data into the formula and then we will get 1.3114 terawatt hour, sorry. Alright, next we have I will show you the simulation for Lagrange interpolation. Alright, for the simulation method, we decide to use Maple for our problems. So this is the data for our problems. The electricity generation from solar in Malaysia by years. So we need to simulate the first order of Lagrange interpolation, which is linear approximation. So as stated in the manual calculation, they are the linear approximation formula. So in here, we just need to put the linear approximation formula into based on the data chosen. So when we input the formula, then the software will give the answer. So the answer for this simulation is for the linear approximation answer is 1.22. So this is the same answer as the manual calculation. Next, we have the quadratic approximation. So as stated in the manual calculation, we need three different data from for to solve the quadratic approximation. So we just put the data into the formula for quadratic approximation, and then we will get the answer is 1.22625 terawatt hour. Next, we have cubic approximation. So as you can see here, we need four different data, which is 2015, 2017, 2019, and 2021. This is the third order of Lagrange interpolation. Then we just need to put the data into the formula of cubic approximation, and then the software will give the answer for this cubic approximation is 1.26375. Alright, this is also the same answer as the manual calculation. Lastly, we have quartic approximation, which is the fourth order of Lagrange interpolation. So we choose five data. We need five different data for to solve this problem. So we just put the data into the formula of quartic approximation. Then we will simulate the answer, which is we get 1.311406250. So as you can see, the answer of for this simulation, all the answer is same as the manual calculation. So we can clarify our manual calculation is correct since the simulation from Maple is the same answer. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zamani Amni bin Muhammad Zani. Number mati DE210048 from Group 3 Numerical Method. Today I want to present you about the manual calculation and simulation for method Newton divided difference. Okay, for the information, our group take for the website for solar solar power that being used in Malaysia from years 2013, 2015, 17, 19, and 21, and we need to search for the usage power solar power for 2020. Okay, for the first for the method Newton divided difference, it has a six step to search for 2020 the users power solar power for 2020. And for the step 1, I take the information from the above table and include in the new table for the year, the zero Newton divided difference, first Newton divided difference, second, third, and fourth. Okay, that's step 1. We will put the new table, and we need to list all information we need, and we need to solve. Okay, for the step 2, we need to search the first Newton divided difference, and we will use the information that we get from the above table, the table above. Okay, let we take the first example, f01 f1 for the first Newton divided difference. The formula is f01 equal to f10 minus f00 divide by x1 minus x0. We need to take the 0.27 minus which 0.14 divide by 2050 minus 2013, and we need to repeat the same step at for the rest. Okay, for the step 3, we need to search the second Newton divided difference, and we need to use the answer from first Newton divided difference. For step 4, uh, same like step 3, but we need to use answer from step 3, and we repeat this until step 5. Okay, for step 6, we need to list the all answer that we get from step 2 until step 5, and we need to use this formula for to search for 2020, and for the final answer we get the 1.3055. Okay, for the simulation we use this application named Maple software, because it is used for us engineering student to solve the mathematical apa mathematical solution. Okay, this is the same like this is the same like manual calculation. Just I list the all information I want, and for the step how we can apa how we can get the answer from this application. We need to list, and we need to use the formula 0.27 minus 0.14 divide by 2050 minus 2013, and I enter uh, button enter, and we will get the same answer just like I do in the manual calculation. And we just repeat the step from step 2, step 3, step 4, and step 5. And the last one, step 6, we use the formula in the manual calculation that I give, and we need to list what uh what the information, what kind of information we we want to do, and we want to solve. Okay, and I enter the button, and we get for 2020 the usage solar power in the Malaysia from 2020 is 1.3055. Okay, that's just from me. Thank you.
Okay, the conclusion of case study. The result is accurate because two methods of manually calculated are same as simulation calculation. In this case study, the study also proved a numerical method approaches enable us to address problems that are intractable analytically or have no non-closed form solution. They offer a semantic way to solve a wide range of mathematical and scientific issues, including differential equation, automation, and integration, among others. Besides, we can also estimate value of set within a range of available data point using interpolation. This is especially beneficial when the data has gap or missing value, or when we need to calculate a specific intermediate point. Interpolation fill in the blank and create continuous representation of data. Due to split different maybe computer requirements, making the calculative procedure easier. Okay, that's all for me. Thank you.